Guys, this is Chelsea again, and this is Lab 3, Objective 1. In this objective, I'm going to talk about changing an RGB LED to change colors from red, blue, green to cyan, and then back to red, and then with a splash of yellow. So what I have here is my circuit board and my Arduino circuit, my breadboard and my Arduino circuit board. And the RGB has 4 pins. 3 of them consist of either the red, blue, or the green light, and then the longer pin is the common, which goes to ground. So here's my LED, and then from the 3 pins, I have a 220 ohm resistor coming out of 3 pins, and then the long pin has a jumper cable right here, which goes to ground. And the orange jumper cable goes down to channel 9, and the yellow one goes to channel 10, and the red one goes to channel 11. And then I have my black one as my ground cable going to my Arduino circuit board. So when I also had to program this into Arduino software, and it should look like something like this. And I have a constant integer using the red pin as 9 channel, the green pin as the 10 channel, and the blue, and that's physically stating where the pins are on the Arduino board. And then I have pin mode, which is setting the pins as an output, and then come down here to void loop, and it has digital write, and I have to set the red pin on high and the other 2 pins on low so that the red pin can light up red. And then I do that for the blue and the green, and then to mix the colors for purple and cyan, I have to put the red on high and the blue on high and the green on low for purple. And I just have to keep mixing them like that until I get cyan and yellow as well. And then I have a 1500 millisecond delay on each segment as it switches over to the next light. So when I go to plug it in, it should look something like this. And it blinks green, blue, red, yellow, and back again. So in this objective, this is objective 2, part 1, and I'm gonna set up a circuit which has 8 LEDs, which is here, and then I also have 8 220 ohm resistors, and in this circuit, I'm going to turn on each LED one by one, and then turn them off in reverse, starting with this red light all the way back to the beginning. So what I have here is each LED has a jumper cable, and each jumper cable goes from channel 2 through 9 on the Arduino board, and then I have my other jumper cable that goes from my breadboard to ground on my Arduino. So I had to program this in my software, and it should look something like this. And all it's saying is pin mode is actually setting each LED as an output, and then come down to here to digital write, and this is saying that it's going to have all the LEDs turn on one by one with a delay of 1000 milliseconds. And each one has its own pin that it's set to. So 2 through 9 are the pins. And I have them on high, so that means all the LEDs are going to come on one by one. And then I come down here, and this is saying it's going to have all the LEDs turn off one by one in reverse, starting from 9 through 2. And I have them set on low with the same delay, 1000 milliseconds. So when I plug it in to my computer, it should look a little something like this. 1, 2, 3, 4, and back off again. And that completes the circuit. It's the same setup. This is objective 2, part 2. And it's the same setup with the 8 LEDs and the 8 220 ohm resistors, all going to the circuit board in Arduino. And the only difference is my software sketch. Instead of entering it manually with pin mode and digital write 8 times, I have using a for loop, which looks like this. And I still have to set all the LEDs as outputs, but when I come down here to void loop, my sketch looks a lot shorter than the last time. And so for a for loop, it has the word for, and then in parentheses it has integer, which means I'm setting the pins for the LEDs. And then this I equals 2 is my initiation for where the pin is, and then I is less than or equal to 9 is the LEDs between the channels 2 and 9, and then the I++ means it's incrementing up from 2 all the way to 9, and then when it gets to 9 it'll stop automatically. And then I have the digital write high, which means it's going to turn on the LEDs. And then down here is another for loop, and it's the same thing but in reverse. So I equals 9, starting from, it's going to count down from 9, turning them off, and then I is greater than or equal to 2, so when it gets to 2 it'll stop. And then here at the end is I++, which means it's incrementing, counting down from 9 to 2. And then I have it on digital write low, and this time my delay is 150 milliseconds, which is pretty fast, but I think it's cooler when it's faster. So when I plug in my circuit, it should look something like this. Lighting them all up automatically without having to manually put digital write 8 times for each circuit. And that completes the circuit for this one. So this is objective 2 still, but it's part 3. And in this one, I took away 2 LEDs and 2 220 ohm resistors. And in this one, I'm going to steal the idea from the show Knight Rider, and the lights are going to actually do the same action as the Knight Rider lights on the car. So for this one, it's the same setup, and all I did was I used a different sketch in my Arduino software using Arduino examples, and it's called for loop iteration, and it already has the sketch set up for me, so it should look something like this. And all it's doing is it initiates the timer, and the timer is 100 milliseconds. And in void setup, it's still doing a for loop, so it's setting the starting pin at 2, and then the number through 8 on the Arduino circuit board, and then it's incrementing up. And then in pin mode, it should have the LEDs set out as an output device. And I come down here further in for loop, and all it's doing is reiterating the LED starting at 2 and ending at LED 8, and then incrementing up as it gets closer to 8. And then a digital write is set to high, and the timer is already set at the top. And then a for loop down here is pretty much the same thing in reverse. And what it's going to do is going to look something like this when I turn on my kit. And each one of them is turning on and off at the same time as it travels down through the circuit. And that completes the circuit.